Hello, Jerry. This week is week 3. A little more homework help. This particular video will be on the concepts of logic. Okay, when we look at logic, one of the things I'd like you to think about is switches. Because again, we're talking about things that can be basically on or off. So let's just for a moment think about a power supply. Say it's the power coming into your house from the power company. Here it's Idaho Power, whatever. There's a plus and a ground or a negative. Now if there's a switch, say there's a switch on your wall. Right now I'm going to draw it in the up position. If there's power going to the switch and then that power goes to a light bulb, and the ground is also attached to the light bulb. If the switch is in the on position, ON, then the power is going directly through the switch to the light bulb comes on. If the switch is in the off position, then even though the power is going to the switch, it doesn't go beyond the switch. So no power comes to the light bulb. Okay, so you walk into a room, you turn it on, you turn it off. That's how that works. Okay, now let's just take a look at when we talk about that. We could describe that switch as variable P. In logic, a lot of times they use P and Q, just like in algebra we use X and Y a lot. So let's just draw that diagram again with a power supply. With a positive and a negative. But let's put two switches in the circuit. So the positive comes to the first switch, goes to the second switch, then it goes to our light bulb. Sorry, I'm taking time to make my drawings here. And then back to ground, or basically a closed circuit. Okay, when the switches are both in the off position, power goes this far, but it doesn't go any further than that. Okay? If one switch is on and one is off, then the power goes to the first switch. It goes through the first switch, but it stops at the second switch. Okay? The only way that power gets to the light bulb in this particular scenario is if both switches are on. Then the power goes from the power source to the first switch, goes through the first switch, goes through the second switch, and goes into the light. And what this represents is the AND, A-N-D in logic, or that symbol. So if we were to label this switch P and this switch Q, then the only time that the light would be on, okay, is if both P and Q are on. That's the only time. The other scenarios, P off and Q off, no power on. P on, Q off, no power on. If it turns out that you go the other way, which is to have P off, good thing I didn't say P on, and Q on, again, the power just goes this far and stops. It doesn't even get to the second switch, okay? So with the AND characteristic of a logical connector or logical sentence connector, the answer for P and Q, that only equals true when both P and Q are true. Then that equals true. All other cases, false, true, false, false, true, false, all of those cases, except for the one where they're both true, all of these cases render basically the light being off or false. Okay?